is question 5 of June 2011, Pure Mathematics, paper 1, variant 2. So question 5 says, prove the identity cos theta. One second, let me write this. Write it in green. Cos theta divided by tan theta into 1 minus sine theta equal to 1 plus 1 by sine theta. Please refer to the question. I'll make this full screen now. So how do we do this? Well, we know two things. Tan theta is equal to sine theta by cosine of theta. So we can replace, let me put this in another color, replace this with this. So let's do that. Cosine of theta divided by sine theta by cos theta into 1 minus sine theta, and this should be equal to this. So going to the next page, we have cosine of theta divided by sine theta cos theta minus sine squared theta by cos theta, and this is equal to 1 plus 1 by sine theta, sorry. This should equal to 1 plus 1 by sine theta. Now we take LCM on this, and we have, we take LCM on this, this is theta, this is cosine of theta, we take LCM, we have cosine of theta as our LCM, so sine theta minus sine square theta, and this whole thing is divided by cosine of theta. So we know that it's cos square theta divided by sine theta minus sine square theta, and we know that cos square theta is equal to 1 minus sine square theta divided by, we take sine theta common here, we have 1 minus sine theta, correct? And now we have this equal to, if we take common on this side, we have sine theta common, and we have sine theta plus 1. Now if we simplify this, we'll have, let me just clear this page up. Now if we simplify this, we'll have, let's cross multiply first. So we'll have sine theta minus sine cube theta, I hope you see how I got that, that is equal to sine theta into, I'm continuing over here, 1 minus sine theta, 1 minus sine theta into 1 plus sine theta. So this is sine theta minus sine cube theta equal to sine theta into 1 minus sine squared theta. I hope you can read that there. Now if we take sine theta common, we'll have 1 minus sine squared theta, which matches this side, which is sine theta into 1 minus sine squared theta, and therefore proved. Now if you don't understand this, please email me or ask me questions, any questions you have. We'll go on to the next problem. Let's see the next problem. Now hence solve the equation cos theta by tan theta into 1 minus sine theta is equal to 4. Now this is pretty straightforward. Let's clear the page. Let's open this to full screen. We have to just do cos theta by, cos theta by tan theta into 1 minus sine theta is equal to 1 is equal to 4. Now let's do this. So we found out in the last part of the problem that this was equal to 1 plus 1 by sine theta. Am I right? So what we have to do here is just equate this to 4. Now make sine theta the subject of the formula. 1 by sine theta is equal to 4 minus 1, 3. Sine theta is equal to 1 by 3. And theta you can find in your calculator as sine inverse of 1 by 3, which is equal to 19. Sine inverse of 1 by 3, which is 19.47 degrees. Now I hope you've taken this down. I'll clear the page. There's more than one answer, as they say that the answer should be between 0 and 360 degrees. So making this full screen again, let's draw our unit circle. I like doing it the unit circle way. If you have any other way, then please use that way. But the unit circle basically depicts sine x on the y-axis and cos x on the x-axis. On quadrant number 1 and quadrant number 2, sine x is positive. Quadrant number 3 and quadrant number 4, sine x is negative. So here, sine x negative. Here, we have sine x positive. So we have a positive answer over here. That means our angle is somewhere over here, 19.47. Now, if we want to find another answer for this, it needs to be positive. Therefore, our other answer has to be in quadrant number 2. So it should be another one. It should be another line over here that goes here, where this is our angle. And to find this angle, we know that this is already 19.47 due to some simple geometry. So we do 180 minus 19.47, and we get our answer as theta also equal to 160.53 degrees. I hope you see how I got that there. So if you have any questions, please ask. My email, it's on my YouTube channel and my website.